How can a computer discover that a king is related to a queen if nobody ever tells it what a king or a queen actually means? A computer doesn't understand language. It doesn't know history. It doesn't know royalty. It doesn't know what a crown is. And it certainly doesn't know that kings and queens are related. Yet somehow, after training, words like king, queen, crown, royal, and palace end up close together in a mathematical space. How is that possible? The answer begins with a surprisingly simple idea: predict nearby words. Let's start with these training sentences. The king wore a royal crown in the palace. The queen lived in the royal palace. The prince saw the golden crown. The king and queen ruled the kingdom. At first, these are just words, nothing more. Skip-gram now slides a small window across the text. At each position, one word becomes the center word. Right now, the center word is king. The nearby words become the context words. From this single position, Skip-gram creates several training examples. King predicts thee, king predicts war, king predicts a, king predicts royal. These training pairs are added to the dataset. Then the window moves. Now war becomes the center word, and new pairs are generated. Then it moves again, and again, and again. Sentence after sentence, word after word, the model keeps generating training pairs. Notice something important. Nobody has told the model what a king is, or defined queen, or explained royalty. The model only sees patterns, just which words appear near other words. Eventually, millions or billions of training pairs are created. Now let's move to the next visualization. This is where learning begins. At the start, every word vector is random. King is somewhere in space, queen is somewhere else, royal, crown, and palace are scattered randomly. The model has no understanding of language. Then training starts. The model sees a pair, like king predicts royal. It makes a prediction, often wrong at first. That creates error. Loss. You see that loss in the graph? The model adjusts its vectors to reduce the loss. It repeats this millions of times. King predicts royal, king predicts crown, queen predicts royal, queen predicts palace, over and over. As training continues, the loss decreases. The model gets better at predicting context. And something remarkable happens. Words that appear in similar contexts move closer. King moves near queen, king moves near royal, queen moves near palace. The model is building a map of language. Eventually, the space is organized. Words with similar meanings cluster. For the first time, language is geometry. Words become vectors. And that's the foundation of modern language models. It all starts with one idea: predict nearby words.